Hi, I'm Everett. Welcome back to the shop. This time in the shop, I've got an interesting little project from one of my neighbors. It's kind of funny how, as time goes on and you're a bit of a hobbyist, messing around with machine tooling and metal and building things just for fun. Um, it's just kind of funny how sometimes word gets around and you start showing your neighbors some of the stuff you do, and next thing you know, hey, I got this broken thing. Do you think you can make one of these? And well, sure enough, my neighbor has a Mastercraft bandsaw, and there's a little cheap pot metal cast something or other piece that is used to tension and adjust the one wheel, the one drive wheel for the band. This is some of the cheapest pot metal cast crap I've seen, but the one that we're going to make is going to be out of steel, so he shouldn't have this problem again. Downside is he may find the next weakest link in the whole machine, but at least this part won't break again. Fun thing is, it's metric. I mostly work in imperial. It's not that I can't work with metric mentally, it's just most of my tooling is in inches and thousandths of the inch. What I wound up doing was actually taking this piece in a digital caliper, and I went and got on Fusion and made a diagram with using nominal dimensions, because I don't know if you can see it at all in the camera lens there. Sorry, I'm a bit shaky. It being that it's die cast, it has to have a little bit of angle or a little bit of relief on the sides so that it'll be popped out of the mold when it's cast. Well, we're going to use nominal dimensions. We're going to make the edges square. If I have to, I'll take a file to it and give it a bit of clearance to fit it back to his bandsaw, and then I'll readjust the plan if necessary for anybody else who ever has a problem breaking one of these on your Mastercraft bandsaws. Not that big of a deal. It's all mill work, but the thing is, without this, well, bandsaw is pretty much useless. So, it's just kind of sad that they had to use cheap pot metal, but I guess they have to build to a price point somehow. So to start with, let's take and grab our flat bar, and we're going to go cut a chunk off the end. I know it's not the world's most spectacular saw, but it sure beats having to cut it by hand. Just for roughing it out, I'm going to add a bit of material at the bottom, come up here to the top, make a line. That'll give me enough space that I can clean up the top and bottom and cut the material to length. Okay, first things first, I'm going to take a slice off this side with the milling cutter. Then we should be able to, once you get a flat spot or a flat side here and flipped over, then we should be able to start being able to cut it down to thickness. 20 thou cut on. Thou cut. This should clean this side up. Okay, a quick deburring and a wipe. That side looks good. Now it's time to clean this side up. 26.8 millimeters, give or take. We're going to have to take off roughly, well, 1.3 milliliters, roughly 51 thousandths. Well, the shortest one I'm getting here is 25.49, so that is as close as I'm going to get. One handy thing about my little square is that it's actually narrower than half an inch. So to clean up the ends of this material, what we're going to do is we'll set it in there, and we'll set it up against the little square. If I clamp over here, again, what's going to want to do is actually take the jaws and cant them this way. I deburred the little piece that actually was cut off of there. I'm going to set that in this end. That'll equalize the clamping forces either side. I'm going to skim the end of this off. We'll figure out what our length is and cut it a length after that. Okay, touched off. So we now have one square end. off. Let's add 20 thou. And we're going to take a measure. 59.8. We need 56.5, so we need 3.3 millimeters off, which is roughly 130 thou. $56.75 millimeters. Yeah, 0.25 millimeters off, which is roughly 9.5 thousandths. $56.56. Yeah, we're close enough. I mean, yeah, 0.6 of a millimeter, 2.5 thousandths. It'll work. We got our parallels in. We got our block laying in the vise here, nice and clamped down. Both parallels are snug. We're just gonna take a skim pass off this side, figure out how thick it is, and then we're gonna cut it to thickness on the other side. Alright, something's not right here. I gotta figure it out. Something's not right here. See how it's cutting only on the one end there? I'm really suspicious that there's something wrong. I'm gonna reset this up and try again. Who knows, maybe the part actually is that, you know, odd out of shape as far as, you know, thicker here on that side. Anyway, I cleaned the vise before I put it in with the first time. So again, I took her apart, cleaned everything up. Parallels are solid again. If it cuts that same way again, then I can just assume it's within the actual piece itself. It's hot rolled. Maybe it is a little bit out of dimension. I'd rather be safe than sorry. Okay, let's pop this out. I'm going to pop it out and deburr it, and I'll bring it right back. Got it all cleaned up again, deburred, remounted. It's 12.34, 12.35 millimeters thick, give or take. We need to take 2.3 off, which is roughly 92 thousandths of an inch or so. There's roughly 30. Getting roughly 10.8, yeah, 10.8 millimeters. So we need to take, yeah, 31.5 thou, give or take. I'm still not sure how much I trust that dial for the quill down feed. I'd like to get at least some other, like I say, a digital caliper or something mounted just for a second opinion. There we go, 10.03, 10.04. We're within a couple thousandths. Good enough. I'm very careful. Just gonna take the burr off this end, just so I don't scratch my vise too much. Now, what I want to do is I want to find the edge here and the edge there. We're going to start by finding the edge of the mill vise. There we go, that's 0. Doing the math, 12.75 millimeters comes out to roughly 502 thousandths. Now, with the lead screw pulling this way, taking up the backlash, pulling this way, we are now 100 thousandths from the edge of this vise jaw. So theoretically, we should be able to go then 1, 2, 3, 4. That should put us right to the middle of that block, which it does. But we have to go forward a hair and then back, take up the backlash. And don't go quite to 0. There we go. But we've added 2 thousandths, so now I can lock off the Y. We are now in the middle of this block, in this axis. This way at least we're pushing on the lead screw, so it's going to be taking up the backlash in the opposite direction. Yeah, there we go, there's 0. We have to take the piece of material and move it this way by 24 millimeters, which is 948 thousandths. But first off, we got to go 100 thousandths to deal with the edge finder. So now we're right over the edge, the center line of the quill. That should be 948 right there. I want to drill and tap this hole before cutting the outside features, simply because it'll be easier to hold this piece right now because it's still a square block. I know I could spin this a little faster, but I just need to spot it. Here we are. This cutter is way too big to be running chatter free at the speed I've currently got the mill set at. Changing speeds is a nuisance. So we'll clean it up by hand. I just flipped it around after deburring it. Slightly loosen the jaw to self-center itself. Yep, this is definitely a handy tool. Thanks again for the idea, Chris. What I need to do next is drill. I want to drill this hole that goes through both these ears. I want to drill it before I do this notch. And so it's actually in the center of the piece at 5 millimeters in and 4.81 from the edge. I'm going to set it slightly over the edge of the parallels so that I can clear the parallels when it comes time to drill. What we're going to do here is we're going to just find the edge of the vise again. Yeah. 0 on the dial is okay. We need to come 196 thousandths from that far side. We already had 100 because of the actual center finder. Theoretically, that should be 196. Now this needs to be 4.81 millimeters from the edge. It's 190 thousandths. Center 0 on the slide. Yep. So 100. Yeah, this is what got me. Let's go another 100. There. For this, I'm going to use a number 6 drill because that's about the closest I can get to what the size of the hole is. There we go. Air touched off. Got the dial, or the little wheel up top here is or zeroed as accurate as it's going to be. We need to make our groove 512 thousandths deep, so just a hair over ½ inch. Now, you guys get the idea. I'm going to pause here. We should theoretically be 490 thousandths at the moment. As far as our depth, we need to get down to 512. I'm just going to gauge it with the old one. Yeah, I still need to come down here. Yeah, well, try another 30. Bang on. That's it right there. Or the groove itself should be 15 millimeters wide is what we want. Okay, so yeah, it says 14.8. Okay, so if we're 14.8, we need to go each way, this way, approximately 1/10 of a millimeter, so 4 thou. And then we should be able to move this way 8 thou, and that would be the width of the groove. And 14.99, I'll take it. We've flipped it on its side, got it set on A parallel here because the next size up parallel from what I had before, two of them are slightly too thick. What we need to do now is, I'm going to do this just as a secondary witness mark. We need to measure 24 millimeters from this end, which is our reference end. And that's what we're going to be cutting toward as far as our notch. Notch has to be 3.75 millimeters deep, or off each side rather, and 3.75 millimeters is 148 thousandths. Now what I'm going to do is I'm going to get up close to the line, but not take the line. Start light, let's take 30. .7271. Need to take 28 thousandths. 24.03, I'll take it. All I have to do is cut the rest of that off the same height. We're going to leave our quill locked. I'm going to flip this piece over and do pretty much the same thing I did on this side. Only difference is I'm going to have to locate and reference off of this surface here because this isn't going to be touching the parallel. You don't want to watch me do both sides. I'll pause it and I'll bring you back when we're just about, well actually we'll be pretty much done at that point. We hit our target, 24.02, 24.01 I can see on the dial or gauge screen. There we go, a little bit of deburring and then we can get his bandsaw back together. Well, I'm happy how that one turned out. Again, the swirl pattern on there is just because I don't have fly cutter, otherwise I would have fly cut both sides. Looking at it, you can see where there's actually a cross hatch where the two mill-end cutter paths crossed each other, and if you see a cross hatch, that's a good thing. Yep. Lay the one on the other, and everything lines up. I like it. So once again, I just have to say thanks again for watching. Thanks for subscribing. And thanks for everybody who just wants to come hang out in my shop with me. It's kind of fun with this whole YouTube thing. I get to hang out in other people's shops, and it's cool when other people want to hang out in mine. I should probably get out of the shop, seeing as it's 20 after 1 in the morning, and the better half and little man are both sleeping and have been for a while, and I probably should go get some sleep because he's probably going to be up in, 4.5 hours? So anyway, thanks for watching, thanks for subscribing, see you next time.